Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back, powered by Hark. My name is Paul Webb. I'm the founder of B2B Energy, and I'm your host today. Wherever you're listening to this podcast, I truly hope you are safe. We would like to thank our episode sponsor today, who is Ecosync, and more about them as the podcast goes on. So this is episode 47, where weekly I present to you experts from around the world. And today I'm back home in the UK. The purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. My guest today brings science, technology together to address intelligent controls in buildings. She's a chartered engineer and a chartered scientist with a PhD. She has developed innovative technology with her team to address heating controls within a building. So without any further ado, I give you Dr. Zsuzsa Meyer. Good afternoon, Dr. Zsuzsa, and how are you today?
Hi, good afternoon. I'm very well. And yourself?
Yes, very good. And I'm loving this beautiful summer that we started to have in the UK. And is it nice and good weather where you are at the moment in the UK?
It is very, very hot and sunny in Oxford. It's really unusual weather.
Dr. Zsuzsa, I've met you. We've been doing lots of work. We've been looking at some interesting projects. And I really like your technology that you've developed. But before we go into that in more detail, I'd like you to possibly, if you can introduce yourself to our audience today and give us some background to you as an individual and where you've come from regarding this industry.
Okay, yeah, sure. So my background is engineering. I did a PhD in bioenergy, and then I ended up in the UK working with the European Bioenergy Research Institute that opened back in 2009 in Birmingham. So I was one of the very first employees. I was in charge developing laboratories and also developing new techniques to characterize biomass and biofuel. Then I ended up in Oxford doing the exact same research and development. So it was all about bioenergy, renewable energy. But I became more and more interested in energy efficiency. So even though finding the energy source of the future is an extremely hot topic, but it just makes sense to solve a problem that go one step back and make sure that we are not wasting energy. So I started to look into energy efficiency of the buildings, because most of our carbon dioxide emission, energy consumption is coming from our buildings. People think that it's agriculture or transportation, but no, the number one source of carbon dioxide is the buildings. So I became very much interested in the energy efficiency of the buildings, and this is what Ecosync and my team, this is what we are working on developing at the moment.
Brilliant. There was something you mentioned to me on our first meeting about energy, the best energy. What was the saying?
Yes. So when you think about finding the energy source of the future, it's the all the talk is about renewable energy, right? We moved away from discussing nuclear power. Fossil fuel is still the number one energy source, but by now we are really aware of all the issues around using fossil fuels. So everyone is focusing on renewables, but the thing is that they are very, very expensive. They are still very expensive, and it just doesn't make sense to waste that. And I believe that the best energy is not the renewable energy. The best energy is the energy that we don't even use. So hence my interest in energy efficiency.
And I love that saying. And one day you'll give me permission to start saying that myself, yeah, on all my posts and things, because I think that's a really amazing saying. So are you still looking at alternative fuels and things? Is it something of your passion? You're still looking at that side of it, or you're purely focusing now on energy management?
No, I still work on various projects as a kind of consultant. I'm a part of an international network of biofuel experts, bioenergy experts. But to be honest, I don't really have time to take on new projects because our current technology is growing very fast. So this is my current interest. But yes, I do have the bioenergy background, and generally any green technology because we just have to work on all of these. It's there's not no just like one solution out there. We have to develop all of them. However, my passion now is energy efficiency.
Yeah, and you've niched into the heating sector of that, haven't you?
Yes, that came just kind of very natural, and it was also based on experience. So when I was working at Oxford University, it was, well, you can imagine the building stock. So we've got some very very lovely buildings from the 14th century. We've got extremely modern buildings, research facilities, and then anything between the two. But wherever I went, it was the same problem over and over. You have a meeting, you book your meeting room, you turn up, and then what you experience is that the room is freezing cold, or it's the opposite, it's really, really hot. So you're just wasting your time looking for a thermostat, looking for a receptionist, a facilities manager, and then you just give up and open the windows, even though you know very well that you are wasting energy. And it was something that I think all of us experienced before COVID when we worked in our office environment. And I just couldn't believe that I was like sitting in the middle of Oxford, surrounded with the smartest people, and no one had a solution for that. And it was very very strange. At the same time, I also had a master student who was from the Middle East, and he asked me this very very simple questions like, why do you guys heat the empty rooms? Whenever I'm walking into your room, it's empty and it's already heated. And I didn't have an answer because this is what we do, right? We just heat empty rooms. So then I realized that the two issues they are linked together. It's like no control, no room by room level control, and that's one of the reasons why heating is so inefficient in our buildings and wasting so much energy. I can even quantify it. So it's roughly 70% of the commercial buildings are empty. So it's 70% of the rooms in commercial buildings, and these rooms they waste roughly 40% of the energy. So in case of organization with hundreds of buildings, that could be 4, 5, 6 million pounds wasted on energy
And
on empty rooms.
And that could be made simply. It's a simple approach, but a very effective approach, isn't it?
Yeah, so the solution is simple: stop heating empty rooms. This is what we are all about. So when we looked into the problem, why is it a challenge? What's holding commercial buildings back to become more efficient? Why were the empty rooms wasting so much energy? We kind of narrowed it down to two challenges, two issues. One is that they just don't have the location-specific, granular, real-time information on occupancy. And then the other problem is that even if they had that information, they don't have the room-by-room level control. Of course, there are smart buildings, but it's like less than 1% of the buildings are smart. So we are talking about everything else. We are talking about office buildings, education, hotels, hospitals, and so on and so on. So we wanted to first just find the existing technology that could answer that problem, and what we saw that there were very very good solutions for the domestic environment, like the Nest, the Hive, the Evo Home, these smart temperature control technologies, but they are not scalable. You cannot use them in a commercial building because of many reasons, mainly technical reasons. So we first try to kind of just adapt one of these technologies. I hope it's okay to maybe I don't mention a brand, but we invited them to give us a proposal in a building. I think the building is from the 14th century. They came, they had a look at the building, they were like, okay, we are not touching it, and they left. And that's happened over and over again. So the existing technologies, they were just not suitable for retrofitting for an average building that has no fancy building management system, just something very basic. Or even with the fancy building management system, they just don't know how to how to use it properly, which is also a quite common issue based on my experience. So first we tried to identify existing technologies. When we couldn't do that, then we started to develop a technology that went through lots of iterations and lots of different pilots, and where we are now is like very, very far away from the original concept we had in mind through lots of different stages.
So my background's BMS, and if I looked at a building, I can see why they were saying a very old building, you're going to need to run a lot of sensors, and for what you want and how you're controlling, you go very granular. A BMS system can't do that, and if we're asking them to put loads of sensors in, the cost starts to go up. And the infrastructure and all the logistics of putting a big BMS system in there in the end. And what I like what you've done, because you've gone very granular, but it's a low cost as well, because it's cost effective, more efficient. And you achieve the granular side by controlling the radiator, not the building and the main system.
Yes, that's correct. So the first version of the technology, we designed it for buildings with wet heating systems. So these are the traditional radiators in the rooms, and then most of the BMS based approaches, retrofitted smart heating approaches, is that they communicate with the central system. Instead of that, we are communicating with the individual heating devices, so with the radiators, and that's actually how we save energy. So when we find an empty room, what we do, we reduce the flow of the hot water entering that room, and this way the returning water temperature is higher, the boiler is working less to heat it back up. So that's the saving opportunity. And yes, we wanted to design something that it's a really, really not hardware heavy, because we wanted to simplify things, make the installation and the maintenance as simple as possible. So the only hardware requirement is to maintain that communication and control in the rooms. So we are communicating with the individual heating devices, radiators, and then when it comes to collecting data, we have moved away from the sensor-based approach. This is where we started. Of course, everyone else is looking into IoT sensors these days, and they are getting cheaper and cheaper. But I believe that the limitation of these technologies is not the cost, not the manufacturing cost of the sensors, but then on the ongoing maintenance, and then also the installation pain. So we wanted to design a plug-and-play solution that does not require we just can't really imagine having a team in every single city, in every single country to do that installation for the building. So we wanted to create something that either doesn't require an installation or can be done by the facilities management of the building, the existing facilities management team. So first we started to use third-party IoT sensors, people counter devices, PIR motion detectors. We were always just looking for the cheaper and cheaper solution. We even went all the way to develop our own sensors. So we did manufacture two type of motion detectors, the PIR sensors. The first version was a battery operated one that still had the ongoing maintenance, the installation and the maintenance problem. Then the next version was doing energy harvesting, because we wanted to see if we can create like even the sensor part, if it could be like a sustainable one, no battery, no maintenance issues. So we teamed up with a Swedish company to add a solar panel, completely organic material that's harvested energy, light, to convert into energy for indoor. So that's a specific challenge to do indoor light harvesting. So we ended up with these sensors. That was great, but then came the issue of like who's doing the installation, and then we wanted to see it. We took it as this kind of next challenge. Can we collect information without sensors? So that was a big pivoting point for us, and this is what we do now. We now, instead of using sensors, we harvest the information, pull the data from the building, the data that's already there, And so we are, I'm not sure if you are a clean tech company or a data company, because our solution is very much based on the data that we are receiving, data generated by our users and by our buildings. We use that data. We are using machine learning. I know everyone is using AI these days, but yes, we are also using machine learning to do both optimization and prediction. We see the pattern of the building, how people are using the building, so we can even tell how they're going to use the building, and this way we can adapt the energy control of the building. So it's a dynamic energy management, adapting to the changing occupancy levels. Before COVID, it was something that it was like kind of hard to explain, but now everyone knows about it. Like, yes, I might go back to the office 1 day per week, 2 days per week, but that's not, might be the same days. So yes, it's changing a lot. The patterns are changing a lot. It's not 9 to 5 type of how we work in offices, and this is where we can have we make the buildings more efficient by
how quickly does the AI learn the building? How was the timescales of installation and for that to start really getting a hold of the control?
So when we set up a building, it's the first level of control. It's not AIB. It's not immediately. So the current algorithm that we have, it requires two type of calibrations. We do a calibration like during the heating season and outside of the heating season. So that requires 12 months to learn. But we are also working on a completely different approach that would allow us to do that type of control technically from day one. This is one of the ongoing developments. Our head of AI, he's also from Oxford University. His background is actually astrophysics. So we are not just a team of engineers any longer. We also have an astrophysicist. So yes, this is his current challenge. This is what he's working on with the team, to be able to do this type of prediction almost from day one. If you're interested, I can go into details.
I'd like to just touch on one thing. So we had our first meeting, and typical expert of within the energy industry and my background, I raised loads of questions and loads of issues, and I said, well, how are you going to address this? What's this? And at the time, you didn't have the answer, but very quickly, your team just moves very dynamically and come up with all the different solutions. So we talked about the TRV control, having to maintain the battery. Well, very quickly, you address that problem, and you've got a self-generating TRV, which is absolutely amazing. We then talked about the drawings and about, tell us about how you go and implement this system, because you don't really need to go to site, do you?
No, so that's also one of the biggest changes based on feedback. So everything we are doing is based on user feedback and experience. So we are engineers, so we are testing lots of things. And one of the things we learn is that yes, we do site visits, but what we see is pretty much predictable. So we don't need too much information on a building to be able to design the system and set it up in the cloud for the control part. And yes, the second generation of the technology that's coming out in September, it will be so much a plug and play system that we won't do any site visits. And we are aiming for system, something that any users, facilities manager, so the tenants, the landlord, or the FM service provider can just order online, inputting some basic information on the building, few clicks, and then you receive the controller part with instructions. So we believe that's the enterprise solution that's needed, something that's extremely simple, and we can skip that step of expensive site visits. It's not just the money, but it's the time of both parties to arrange this type of things, and it's actually not necessary.
And will the organization be able to identify the savings they're making? Because it's quite hard to identify the savings regarding a radiator, whether it's going to be on and off, or the temperature outside. Is there a way that the organization will be able to sort of qualify the savings made?
Yeah, so that's actually not that complicated. So even before doing any modifications in the system from existing data, we can do quite accurate calculations. So that's analyzing the energy pattern of the building, compare it with weather data, doing something quite basic baseline weather corrections, then adding information on occupancy, and then based on that we can estimate how much energy is wasted by the empty rooms. So that's kind of basic. What's also missing in the buildings, not always, but quite often, is that they don't really have the very accurate metering. In place. They have like a boiler serving multiple buildings or different type of tenants in an office building. So it's difficult to break it down and even get a good idea on the baseline. So because of that, we wanted to see if we can do more accurate real-time data collection and calculations. And like everyone else, we looked into flow meters, heat meters, ultrasonic devices that does not require you to cut the pipe and place the device inside, because that would require you to depressurize the whole building, and so on and so on. I'm sure that your audience is familiar with this type of issues. So that's the cost and the ongoing pain with this type of accurate sensors. We also looked into these heat calculators, estimators that you put on the surface of the radiator, and so on and so on. So we looked into all these solutions, but then with the controller part that's controlling now the flow of the hot water, which is pretty much just replacing the top of your existing TRVs. We can collect enough information to do quite accurate calculations on the energy output of every single radiator in the building. And based on that information, and then other information like current temperature, weather data, which is public information, it's available for everyone. You can even calculate things like the heat loss of a specific room. So you can map the building quite well in real time. So we receive that data in every 5 minutes. So almost in real time. And this way we can actually offer lots of additional services based on these data. So we have a leaderboard coming out for education, for student accommodation buildings, where the users can see their own carbon footprint. So it's not the carbon footprint of the building any longer, which is like, it's just a number. I have nothing to do with that. I'm not the one responsible for that. I'm not the one paying the bills. Why would I care about that? But when it's your own carbon footprint in real time, reflecting on your behavior, are you using the room? Are you changing the set temperature of the room? Are you opening the window, leaving your window open? So that's something that's the way to educate the users, show how you're doing compared to your neighbor. We are interested in setting up competitions between buildings, which is a feature requested by education sector. So there are lots of things you can do once you see the energy output of the individual devices or the carbon footprint of the individual users. And of course, you can look into billing your tenants based on real consumption, and so on and so on. So you can do lots of data with lots of things once you have good data.
Where do you see this technology really being implemented? What type of sector? Is there any particular niche sector you want to be focusing on? You've mentioned education.
So we definitely wanted to design a solution for commercial buildings, because again, domestic buildings, I think they've got very, very good solutions already. So when you talk about commercial buildings, then it's mainly office buildings, education, hotels, hospitals. Manufacturing, it's not so much, because I might be wrong, but they are running like 24/7. So like the empty room is not really an issue, or shops with very specific opening times. It's easy to have a timer on your boiler to to adapt to that. So these are not the challenging type of building. So hotels, hospitals, office building, education, and then if you look into education, then a primary school works completely different than a university. Very, very different type of conversations. But right now we are pretty much focusing on office buildings, business parks, and we might get back to hotels. Right now the way they got affected by COVID, they have other problems, to be honest, and then energy efficiency, and then of course the sport facilities. They are very quite interesting type of building type. So yeah, these type of buildings.
Yeah, I've used this type of technology on my radiators in my house, and it's made significant savings because I was able to shut down my radiators in rooms that I didn't use. So when my boys were staying with me at the weekends and during the week, I would have the heating on, and then when it wasn't there, I'd shut it down, and that made some really significant differences to my heating bill. And I can see that doing that on commercial buildings, hotels specifically. You know, when they get back to normal, when they may have certain rooms shut down, you can link it all into their the booking system, because it's all sort of in the cloud, isn't it? Your system. So it all can be
it's all
together.
online in the cloud. Yeah. So we when we first looked into the room booking system integration, it looked a bit scary because there are so many different solutions out there, and then they would. We said that it would require us to develop an integration for all of them, an API, but then we managed to design a quite universal approach that works with most of the room booking systems. This is the question what we get is like, what about the information? Don't worry, we don't see any personal information. For example, a hotel, they already have cleaning rota, so the cleaners, they don't see the guest information. What they see is like, is the room occupied or not? Does it require cleaning or not? This is exactly the type of information we want to pull from the room booking system. So we do not identify users. We don't want to. And then yes, that what you described as your experience in your own house about empty rooms and adjusting the temperature. It was very, very strange that type of technology was not scalable, and I think we managed to really understand why and do the modifications, do the communication range changes, improvement, and also moving away from the battery operated devices, because if you have hundreds of radiators, that requires hundreds of batteries, and no one has time to change those. So it was important to bring back the energy harvesting feature and technology.
So you're addressing the challenges as they come. Is there any challenges that you're working on at the moment that's going to make the product even better?
So the second generation is coming out with a new type of gateway, with a new type of energy harvesting feature. We are also rolling out the carbon metering features for all the users. So that will be both on a dashboard that you can display in the building. One version will be on the dashboard for facilities managers, and then there will be a different version for the end users on their mobile phones. That does not require the end users to download any apps. That was also quite important for us to make it as easy as possible for the end users to interact with the building. I would never download an app for a building where I'm staying like for 2 nights or just arriving for a meeting. So we had a different approach there, not an app based. So once that generation is out, then the machine learning features, they are quite important to so that requires constant development. There are like so many things we can do with AI. And then after that, we are very much interested in integrating fan coil units and other type of heating, cooling
the rest of the building
devices. So the cooling market is actually wasting even more energy than the heating. market. So that's it. Just makes sense to do pooling integration as well.
And is Ecosync going to look to focus on different technologies? You're going to focus on other sectors within the energy, like cooling, lighting, maybe. Are you going to be looking at other elements of it?
So not really, because of two reasons. One is that Lightning, they already have very good even commercial solutions, and they don't really require our type of intelligence. So if you walk into the room and then a PIA motion detector picks it up and then and turns on the light, that's good enough. It's not good enough for heating. It's not good enough to start heating when you walk into the room. So this is why we are not that interested in lighting control. Heating is a more challenging area. So, and we like challenges. What we are interested in is really the next challenge of our users. So currently it's energy efficiency, and I believe the next challenge will be the grid management. So decarbonizing their grids, and then how do they do that once they start to produce their own energy on site? They have to make a decision if they are storing that electricity or trading. Then there are different ways of optimizing that. What we want to see if we can improve that even further, the existing kind of decision making with the additional data that we can provide on the building. So that's the pattern of the users. If we can even reduce the risk for the energy providers, for the grid management, to reduce the risk around the high end users are using the energy when they're using it, and so on and so on. But that's much more like a 5-year plan for Ecosync, this very data driven grid management challenge.
And currently you're operating in the UK. Have you got any ambitions to expand into overseas, into different countries?
So yes, the current the launch of the second generation will kind of allow us to send the technology overseas without having a team. We won't need to set up sales office or a technical team at every single location, so we won't have that type of geographical limitations. So yes, that's something we had in mind when we designed the system. And of course, if you're looking into cooling integration, then there are certain parts of the world who could really benefit from that. So that's the Middle East, certain parts of the States, and so on and so on. So we are constantly analyzing these markets, but that's more like a 2023 plan for us to go international.
I like the way you've got a roadmap. It's really interesting to see you've got a roadmap regarding your development of it and regarding your portion, the forecast of where you're going to be taking this technology.
So we have a very analytical team. So we analyze the market, we analyze everything, and once you start understanding the pattern of the data, you can make these decisions. Really reduce your risk. So that's we apply it both for technology development and for business development.
Brilliant. So, Dr. Zsuzsa, it's great listening to you about this technology and this product, and I've been following it for the last 3 months and seeing how it's evolving. It's absolutely amazing technology. I like to put my guest on the spot and ask that key question. Is there anything that you can give back? You've done so much for the industry already, but is there anything you can give back today as a takeaway for our audience?
So based on everything that we learned from our buildings, the commercial buildings so far, there are challenges like they don't have the data, the occupancy pattern and data. They don't have the room by room level control, and so on and so on. So we see the scale of the problem, and what we see is that less than 1% of the buildings are smart, and the rest really need Ecosync.
So, Dr. Zsuzsa, it's been a real pleasure talking to you today. It's nice to be in this position where I'm interviewing you rather than you sort of on the other side today. It's been really sort of good to listen to the story in full and the background of it. So I really appreciate that. And I'd like to say thank you very much for your words and what you're doing for the industry. And secondly, I'd like to say, please, you and your family, be safe.
Thank you. And thank you very much for having me.
Thank you for our special guest today. And thank you for our sponsors, B2B Energy, which can be found at b2benergy.co.uk, and Clean Energy Revolution, which can also be found either through various different social media networks. Type in hashtag Clean Energy Revolution. That leaves me with one more thing to say. Be safe.